Hey there, this is Kushal, and in this video I'm going to tell you about Central Limit Theorem. So Central Limit Theorem is one of the most important concepts in statistics. So if you are new to my channel, please consider subscribing it as I upload a lot of informative videos regarding statistics, data science and rest of the AI domains. So in order to start understanding the Central Limit Theorem, we first need to assume that we have a data. And in that data, let's assume we have some random numbers. And if you are studying statistics, you guys would be knowing that data comes from a distribution. So let's assume this data is from a random distribution. Now what we have to do, we have to take some random samples from this data. And the criteria is the count of values should be greater than or equals to 30. What we have to do, we have to take a significant amount of these group of values. That means we have to take, let's say for example, 100 group of random numbers. Now we have to do the mean of all of these 100 groups, and if we try to plot the distribution function of the means that we have taken, do you know what we'll get? We will get a Gaussian distribution. Yes, that is Central Limit Theorem. Now after understanding this, if I will state the whole Central Limit Theorem, you'll get to know what it is trying to say. So, the Central Limit Theorem states that if you have a population with mean mu and standard deviation sigma and take a sufficiently large random sample from the population with replacement, then the distribution of the sample means will be approximately normally or Gaussian distributed. I hope you got it. If we see in this theorem, it is saying that no matter from what distribution you take some random numbers, if there is some mean of that distribution, there is some standard deviation of that distribution, and if you take some random samples of from that distribution, that means extract some random bunch of numbers from that distribution, and the distribution of the means of those numbers will be normally distributed. And one more thing, the means and standard deviation of the distribution of all the means has mean mu, which is same as the distribution we started with, as well as the standard deviation sigma. I hope you like the video. Good luck. Goodbye. Don't forget to subscribe. Don't forget to like the video. Don't forget to share it, and I'll see you in the next one.